All right, so today we're going to do mass to mass, kind of broken down step by step. So if we have this problem, 4 aluminums plus 3 oxygens yields 2 aluminum oxides. That's our equation. And the question says how many grams of aluminum oxide will be produced from 50 grams of aluminum. So if we look at our map of the world, we're going from grams of our given, which in this case is the aluminum, to grams of aluminum oxide. Okay, and so we're going to take it kind of step by step. So the first step is turning the grams of the given into moles by dividing by the molar mass. So the first thing we're going to do is take our 50 grams of aluminum and we're going to divide it by the molar mass. So when we do our fraction, when we're dividing, our molar mass is going to go on the bottom. So I look on the periodic table for the molar mass of aluminum, and aluminum's molar mass is 27. So I do 27 grams on the bottom and 1 mole on the top. Okay, so that's your first step. So let's do that. So I have 50 divided by 27, and I get 1.85. So I have 1.85 moles of aluminum. Okay, so then now I am here, moles of my given. Okay, now I'm trying to get from moles to moles, moles of my given to moles of my wanted. In this case, my wanted is the aluminum oxide. So I look for the mole ratio between aluminum and aluminum oxide. So my mole ratio between aluminum and aluminum oxide is a 4 to 2 ratio, or I can reduce that to 2 to 1. Okay, and when you're doing your mole ratio, it's always wanted over given. Okay, so I'm going to take my moles that I have, 1.85 moles of Al, and my wanted is the Al2O3, which is the 2 that goes on top. I turned it into a 1 because I reduced it. So 1 mole Al2O3 over 2 moles, that's my given, of Al. So wanted over given. So now I'm going to do 1.85 times 1 and then divide it by 2. So basically 1.85 divided by 2. That gets me 0.925. So 0.925 moles of Al2O3. So now I've done the first 2 steps. I've gone grams to moles using the molar mass, and now I'm gone moles to moles using the mole ratio. Now I need to go, I'm here at the moles of my Al2O3, moles of the wanted. I'm trying to go here to here to get to grams of the wanted using the molar mass of my wanted this time. So molar mass of the wanted is Al2O3. This is where you are going to need to multiply. So molar mass of aluminum is 27. We have 2 of them, so that equals 54. We have 3 oxygens, which is 48. Add them up, that's 102 grams per mole. Okay, so now I'm going to take my 0.925 moles Al2O3, and I'm going to turn it into grams by multiplying. So this time I'm going to put 1 mole on the bottom and I'm going to put 102 grams on the top. Okay, so it's opposite of what we did up here. Up here we were dividing by the molar mass, so we put the molar mass on the bottom. Down here we're multiplying by the molar mass, so I need to put the molar mass at the top. So now I'm going to do 0.925 times my molar mass, so times 102. And that gets me 94 point, let's call it 94.4 grams. So 94.4 grams of aluminum oxide. There's my answer. So that's how you break it all down into step by step by step. Okay? If you wanted to combine it all into one problem, or one big kind of multi-step problem, it would look like this. So you can combine all of those (50 grams), then my mole ratio, Al2O3 to 2 moles Al, and then my molar mass of the wanted. Okay, so this is the same thing as doing these separately. Okay, and depending on where you are, sometimes you're only given mass, you'll go to moles. So then you're not going to do this last step, or maybe you're given moles, you're trying to go to mass, so you won't do this first step. You'll just start here, do the mole ratio first. Okay, so but if you're doing a mass to mass problem, you will do all of these steps. Okay, so I hope this helps. Let me know if you have any questions.